Hello everybody. This video will cover using Excel to value bonds. We have two examples for your homework. One example is asking you to value, to actually estimate the rate of return on the bond based on the current market price. And the other example is asking you to value prices of different bonds. You have 4 different bonds and you want to value them with respect to the change in prevailing interest rates, YTM. We will look, let's start with the first example. This is an introduction to bond valuation and interest rates. In this example, we are asked to value a 15-year bond whose face value is $1,000, a 10% coupon, and semi-annual compounding. This bond is currently trading for $1,034.74. This means that the price of this bond is $1,034.74. We also call it present value or the current price. My example is different. I changed the numbers for you so that you have an opportunity to solve it yourself. In my example, the bond's maturity is 15 years. And that means that this bond's final payment of coupon and face value of $1,000 will be in 15 years. The coupon rate is 10%, and the current price of the bond is $1,034.74. So the first question is, what is the bond's yield to maturity expressed as an APR with semi-annual compounding? What does that mean? APR with semi-annual compounding, that simply means that you need to figure out what the rate of return of that bond is and report an answer in annual terms. Unless specified otherwise, in finance we always discuss things in annual terms, regardless whether that's an applicable rate to the specific loan product or not. So how do I calculate the coupon rate? The coupon rate will simply be, or the coupon payment will be the coupon rate in annual terms multiplied by the face value. This is the amount of money that you will be receiving every year having purchased that bond. But that doesn't mean that you will receive $1,000 coupon. That depends on how frequently the bond specifies its payments. This one is a semi-annual bond, meaning that there's 2 payments per year. So I will adjust this annual payment and divide it by 2. So the coupon payment will be $50. And how many payments? Number of periods refers to the number of payments. I will have 2 payments per year multiplied by the maturity of 15. That's 30 payments. Now, what is my yield to maturity on that bond? My yield to maturity, the function I'm going to use is rate. Okay, if you want to double check your work in a calculator, in the calculator it's going to be I over y. So I'm going to use rate, open parentheses. My end pair, you can click on each of these highlighted variables, and a help window will open up that explains these variables. Here I will explain them to you. The end pair is the number of payments. So the number of payments or number of periods is 30. My payment is 50. My present value is going to be negative price. And the price has to be negative if you're going to put in the payment and future value as positive. If you're going to put in present value as a positive, you have to adjust payment and future value as a negative. If all of them are the same sign, Excel is not going to give you an answer. It's going to give you an error message. So I chose to keep payment as positive, so I adjusted my present value. And since my present value is negative, I can keep my future value as a positive. My type is 0, and then I can leave the guess. Okay, so this is my periodic payment. Okay, 4.78. That is my payment per period. That's applicable to to discount every payment. But I have 2 payments per year, so I have to multiply my rate per period times 2, and that is your yield to maturity. Remember to multiply by 2 you multiply by the same number that you divide the annual coupon payment. If you divide the annual coupon payment by 1, you multiply the rate per period by 1. Okay, so this is your answer. And then a quick check. My coupon payment is 10%, and my coupon payment is 10%. And from class, you know that if a coupon payment is 10% and the bond is trading at premium, meaning that the price of the bond is currently higher than the face value of the bond, that means that this coupon payment must be greater than the YTM. So a quick check allows me to verify that, okay, this number looks okay. Next question is, if the bond's yield to maturity changes to, and I should change that to 8%, if the bond's yield to maturity changes to 8% APR, what will be the bond's price? So My Finance Lab already gave you the column, the rows here and the cells here to fill out. All I need to do is calculate the new price, and it even gives you a tip. Hey, don't forget to adjust for the semi-annual yield or the periodic rate. Okay, so I'm going to do 8. This is my yield to maturity divided by 2. And now, don't forget this comment, a positive value is expected. So I'm going to start with an equal sign. And in order to force the present value or the price of the bond to be positive, I'm going to start with a negative sign. I'm going to put present value. My rate is going to be that semi-annual rate or semi-annual yield. End pair is still going to be my number of periods. My payment is going to be the same. It's going to be my coupon. My future value is going to be my face value. And my type is going to be 0. Close parentheses. This is my new price. Now, notice how the bond's price increased. So the original bond price when we started this exercise was $1,034.74. Now this bond is over $100 more valuable, $1,172.92. Why? This is because of that inverse relationship between bond prices and interest rates. Notice how the yield to maturity on that bond was 9.56 when we first started. Now you're looking at 8% rate, which is a decrease in rate. What that means, you should know that you should expect an increase in the price, and that's what we're seeing here. Okay, so this one checks out. Now let's go to the